We are going to talk about moments in this video. Now, what is a moment? A moment is something that can cause an object to rotate about some pivot. And this is a key quantity, especially when we want to study the rotational equilibrium of a object. Now, for simple illustration, we're going to consider a very standard example of a seesaw. And so we pivot the seesaw over here, and of course, that's my seesaw. Now, how do we calculate a moment? Now, a moment is defined as the force multiplied by the perpendicular distance from the force to the pivot. And so in the simplest example, of course, if I have a force over here, usually this could be the weight of a child sitting on the seesaw or something like this, and this is the weight of the child F, then the perpendicular distance is defined as the distance from the line of action of the force, okay, which is this straight line, okay, and this distance to the pivot over here, it must form a right angle with this line of action. And so, let us look at a more complex example. Let's say the force acts in a funny kind of direction like so. Then how do I find this moment? Well, the trick, of course, is to find the perpendicular distance, the perpendicular. And so, let's follow the steps. Extend the line of action of the force, okay, and then find the line from the pivot that forms a right angle with this line of action, and that is the perpendicular. And so the moment due to this force will then be F multiplied by the perpendicular. Now, moments can either be clockwise or anti-clockwise about the pivot. And so we can see over here, it's a little bit like placing a little Allen key like so. We can quite clearly see that this force will pull this entire seesaw in the anti-clockwise direction. And so we say that this force creates an anti-clockwise moment. And if we look at this guy, okay, again, draw that perpendicular L-shaped line, you can see that this clearly also creates an anti-clockwise moment about the pivot. Now, there is another way to calculate a moment about the pivot. So let's use a clean diagram, also still keeping in line with the seesaw. All right, that's not very straight. Let's draw again. So now let's say we have a force again like this. Now, one other way that I can do this, okay, that's in some situations it may be difficult to find the perpendicular distance. And so what you can do, you can keep the distance to be here from the pivot to where the force acts, D, and then you can resolve the force and take the component F perpendicular that forms a 90-degree angle with D, in which case the moment equals to F perpendicular times D, and that will work as well.